Hello, my name is Stephen Anderson, and this is my code review assignment for my CS 499 class. In this review, I will be going over the three programs I plan to enhance for the final project. The first program artifact that I chose to enhance was my final project for my CS 300 class. It was a parser program meant to intake a text file listing courses and their prerequisites and enable the user to course plan by choosing to load from file and then print out all of the courses or just print out all the information pertaining to one specific course. The program was designed to print the user menu first with four options. Those options are load, print course list, print course information, and exit. When the user chooses to load from a file, it will start the function load file. This function will read down all of the course information in the text file info.txt line by line until it has reached the end of the file. And while going through that process, we'll also use a token function to further break down the file into component pieces that can be used for printing purposes. Then once a file has been loaded, they can choose to print courses list, which will print all the courses in numerical order within the file, or they can choose to print a specific file, which they will be asked for a course number. That will be sent to the function search course, which will go through the different courses in the file, and if it finds one, will then go to print course, which will print the course number, name, and any prerequisites found within the file. Moving on to the actual review part, we have our inspection checklist. And starting with structure, we will go back to the program. And the overall structure of the program is relatively consistent and maintained. Also within the structure, we will see that each code block within the structure has its job, and it does it without any overlapping operations happening within the code. We will also be looking for any magic number constants or string constants. Looking through the program, all our strings and constants all have explicit numerical values assigned to them without anything being changed or anything that is not known for its purpose. Then going over the code as well, we will see that there are a few leftover testing lines that have been commented out, which will not make it into the final Python version of this program that I plan to make for the project. The commenting, though, in itself in the program is relatively consistent. All the comments normally start above the lines, with very few exceptions, and comments all are roughly the same length without too many run-on comments to describe what it is. The only part where I would add is in my for and my while loops. I do feel like there could be some more commenting to further explain what each part of those loops are doing. Further moving on, we move on to variables, and variables within the program all have very consistent naming structures: course number, course name, prereq, or prerequisites, and we see that same form of naming convention used throughout the program, like courses, line, file, All of these names are precise. You know what they're going to do based off the name. There's not going to be any confusion based off of the name of the variables. And our arithmetic functions, while we don't have many in this program, the ones that are here are meant to sort through. So we have for int I equals 0, I less than n, I plus plus, which is just to keep the loop going until I has been reached, or, or until I is greater than n, which n is our course size. Next, moving on to our loops and branches. There are quite a few in this program, plenty of while and for loops, but each loop does contain its boundaries. While n is not equal to -1, it will keep going while get line file and file, while it can still find files within the document. And then for I equals to I less than token info size, I plus plus, so until I is equal to the token info. And our variables do our loops also contain default statements. The main one being our switch case here, where we have case 1, which is load, case 2, print course, case 3, find a course, and case 9, which is exit. But we have a default, which is for non-valid choices, which just puts you back up towards the beginning of the menu. And then we also have, in defensive programming, all of our output variables are assigned. So print courses, courses I, f equals 1, break, whatever. Moving on to defensive programming, all our output variables are assigned. No variable is leaving without being assigned, such as our count, which is being assigned within, moved back up, and used to repeat the loop. Or like in our token vector, where everything is being assigned within, and there's no, the start, which is 0, the end, are being properly moved through the file from beginning to end. In defensive programming, we're also making sure that our memory allocation is deallocated, since we only really have access at one point if stream, we're loading the file into our program. And we have a proper file.close to close out the file after we are done reading the file. The only part that I might look into making more robust in this defensive file reading is to check to make sure that the file does exist before trying to access it. But we do have default cases within the program, since if the while loop can't find any lines, it will automatically close and exit. Well, I also within defensive programming, I do not have a lot of timeouts within it, but I do not feel like they would be needed in this file, in this kind of program, since we are only reading from one file. We're not reading from multiple, and we do not have any instance where it would cause a timeout error. We will now go through the second project I've chosen for this assignment, which is my CS 405 unit testing project. In this project, I was designing and implementing different unit tests to use with GUnit to test with assert true, assert false, or assert NE, assert equal testing, and assert throw testing to see if the test would would throw back the correct response and pass the test. Looking at it piece by piece, we first start with the environment class, which is our testing environment, and it sets up everything for our further along the line environment testing. And the structure in it is set up nice, no loose variables. I could probably add more commenting around it to kind of describe what it's doing. There's no variables to really worry about that have been called and are unclear of either what they are doing or are unused. There's no arithmetic values either, well, operations either, and there are no real loops inside to worry about. Moving on to the class collection test, which will store our test. So create test to house shared data between tests. Do not need to, this was pre-written for me, but I still added some comments to help me understand parts of it. In it, the structure is all consistent. No loops. Well, one for loop to worry about, but that one is not open-ended. It terminates itself. It is designed in a way that does not cause any problems. There are no floating variables or variables that don't have a defined name. There are no arithmetic operations in this one either, and defensively, there is nothing that would indicate it would be out of bounds due to bad pointers, indexes. There's no imported data to test the validity or completeness. Uh, Memory is allocated just for the use of this without any worry about anything being used outside of it. Then we move to our actual test, which will all have a pretty similar structure. All of them have add entries or assert true or assert false or assert equal statements for the most part. And all of them have defined root structure, and the naming is the same in all of them, minus a few things where maybe one test needed a specific variable. As far as arithmetic goes, there's only going to be a few tests, even in the final, that will use arithmetic operations to actually complete. One that is in here is the last test, which is to ensure adding to the previous side is not cumulative. So in this test, we add the entries, then we save that as previous size based off the collection's current size, which will be 15. And then we resize with the previous size plus 10, 25. And then instead of adding again, which would make it cumulative, we just do the same thing, which still leaves it a value of 25. So when we assert false, it still reads it as 25 instead of 35. Loops and branches in this testing is also not something that is currently implemented, but will be implemented in the final part of the project when I do add, file reading and hashing. The final artifact I will be expanding upon is for my database section of the project. In this, I have chosen my final project for my CS 340 class, in where I had to make a dashboard use for a fictional company called Grazo Savor, which focused on dog adoption for the use of dogs in rescue operations, and it would print out a map and list of where the dogs are and what the dogs' descriptions are and what information pertaining to the dogs can be found. In this program, I had my IPYNB file, which was used as the dashboard creation file. Inside this file, we have all the things that went into creating the dashboard to make it operational. We also had, as part of this, our CRUD file, which the CRUD file, the create, read, update, and delete file, was used to issue commands with the database to read, update, or create or delete new data. For my final portion of this project, the final version, I will be adding 4 new operations to the CRUD file to show that I can work with the database and I know how these forms of commands will be utilized. Starting with the first file, the project to Anderson file, which was the dashboard file, we can start the review by looking at the structure of this file. Inside, we see that everything is structured. The app layout is all concised into one area with the comment lines in between. Then we have our dashboard section, which again is broken down based off that. And we have style, we have the pie chart, we have the geolocation, all showing within their ranges and all structured similarly with a very consistent style. And we can look at the structure of our CRUD file. And the CRUD file is also done in a very consistent style that is not abrasive and does not follow common coding standards when it comes to structure. Documentation, though, is where I feel I will need to make the most changes within this project, since my documentation within the files is lacking in quite a few areas. I don't have any comments in major sections of the IPYNB file, for example. And even within my CRUD file, I do not have comments beyond basic comments to show what is happening within each CRUD command. I plan to add more comments in the finalized project. Variables within the project are actually concise. We do not have anything within the project within the CRUD file specifically where a variable that is used is not clearly named based off of what it will be doing, such as result is the result update is the update, cursor to read from the cursor, and delete data is obvious in what it is going to be doing, and result delete, the result of the deletion. In my finalized version, I will have more variables than that because I plan to add features such as delete one instead of delete all that fit a specific name. I will have add multiple, which will add multiple entries into the database, and similar commands. A part of this program which does not actually fit within the review checklist is our arithmetic operations. There are not many within the program itself, especially within the first dashboard file. There are not a lot of arithmetic operations that are not handled by the libraries instead. But within our CRUD file, we will have some arithmetic operations happening as we move forward with the updates and the deletions that focus on specific amounts of data. Loops and branches is another field where we will be reviewing here, and we will see that in our base CRUD file, there are no loops. There are else if statements, but no loops within the basic CRUD file. Moving on to our .ipynb file, we will also see that there are not many loops, but mostly if else if statements. We do not use the loops within this program. There will be loops in the finalized version to go through with the CRUD file to find specific data entries and delete those as opposed to deleting any entry that matches that criteria. Defensive programming. In our program, as specifically the CRUD file that I will be working on, there are no indexes or pointers or subscripts that fall out of bounds of their range. All of them follow specifically what they will be doing, such as the create data is not the cursor. These will be used within their parameters. And we do have exception cases to catch any problems where things like the input are not there. We have catch instances for all of our base 4 CRUD exceptions where the criteria is not there, nothing to save, data parameters empty, no record found, or nothing to delete.